There is a vintage propliner sitting on a quiet apron right now, its sleek, dolphin-shaped fuselage and iconic triple tail casting a long silhouette that recalls the absolute peak of mid-century luxury. To anyone who remembers the golden era of travel, the Lockheed Constellation wasn't just an airplane, it was a rolling piece of industrial art. It was a machine of prestige, representing a time when crossing an ocean was a grand, formal affair, and the roar of four massive piston engines was the undisputed sound of progress. But behind that breathtaking, triple-tailed beauty lay an incredibly complex, temperamental, and demanding mechanical reality that most modern travelers would find almost impossible to believe. Stay with me from beginning to end, because the way this aircraft's massive radial engines were engineered created a maintenance paradox that modern airlines spend billions of dollars to avoid, and it is the exact reason why attempting to run this legendary machine on a modern, fast-paced schedule quickly descends into pure mechanical chaos. If you ask anyone who worked on or flew aboard a Connie during its heyday, they won't just talk about the gourmet meals served on fine china or the spacious, pressurized cabin. They will talk about the sights, the smells, and the raw, physical presence of the machine. They remember the thick, blue-gray smoke that erupted from the cowlings upon startup. They remember the sharp, sweet smell of high-octane aviation gasoline mixing with hot engine oil on the tarmac. And above all, they remember the sound, a deep, metallic, thrumming growl that vibrated straight through the soles of your shoes and lingered in your ears long after the aircraft had climbed into the clouds. To truly understand the gulf between that era and our own, we have to look at how we fly today. Modern low-cost airlines operate on a razor-thin margin of time. A typical short-haul jet lands, taxis to the gate, unloads its passengers, refuels, boards a fresh group, and pushes back to take off again in roughly 30 minutes. It is a sterile, hyper-efficient, and entirely uneventful routine. But what would happen if we took the undisputed queen of the propliner era, a pristine, fully crewed Lockheed Constellation, and tried to force it to complete 10 short-haul flights in a single day under those modern 30-minute turnaround rules? Our simulated challenge begins at sunrise with Flight 1. The air is cool, the runway is clear, and the ground crew is ready. Standing at the gate, the Constellation looks spectacular. To get the day started, the flight engineer must carefully manage the complex startup sequence. Unlike modern jet engines that spark to life with the push of a button, starting the Connie's 4 Wright R-3350 duplex Cyclone engines is a delicate mechanical ballet. The propeller must be pulled through manually to prevent liquid lock, the fuel mixture must be perfectly adjusted, and each engine is cranked slowly, coughing and sputtering before catching with a thunderous roar. Flight 1 takes off beautifully, climbing into the morning sky with its engines humming in perfect harmony. To the passengers, it feels like magic. To the crew, it's a successful start to a very long day. But the moment the wheels touch down after that first short hop, the modern 30-minute clock begins to tick, and the mechanical reality of the 1950s immediately collides with the relentless demands of the present. You know what else should collide? You with that subscribe button on my channel. It helps a lot. As Flight 2 prepares for departure, the first major hurdle appears. Those massive 18-cylinder radial engines don't just use oil to keep things running smoothly. They actively consume it by design. A radial engine is built with loose tolerances that only tighten up once the metal expands at high operating temperatures, meaning oil constantly bypasses the piston rings and burns off. After just one flight, the flight engineer notes that the oil levels have dropped significantly. Under modern turnaround rules, there is no time to waste, but you don't just hook up a quick connect fuel hose to replenish a Connie. Mechanics must drag out heavy, gravity-fed oil carts, climb up onto the wet, slippery wings, unscrew the heavy caps, and manually pour gallons of thick, viscous aviation oil directly into the massive tanks of all 4 engines. By the time the caps are secured and the panels are zipped shut, the 30-minute limit has already expired, and we are officially running late. By the time the aircraft climbs out for Flight 3, a new and far more insidious problem begins to develop. To ignite the fuel in 72 cylinders across 4 engines, the Constellation utilizes a staggering total of 144 individual spark plugs. During the short runway taxi and the low-power descent of the previous flight, the fuel-to-air mixture had to run rich to keep the cylinders cool. The consequence of this is spark plug fouling. Carbon and unburned fuel deposits begin to build up on the delicate electrodes. As the pilot pushes the throttles forward for Flight 3's takeoff, a slight shudder ripples through engine number 3. The flight engineer watches the instrument panel as the cylinder head temperature gauges begin to fluctuate unevenly. One or more of those 144 plugs is failing to fire. The flight is completed safely, but the engine is running rough, and the maintenance team knows that a tedious plug-by-plug inspection is looming if they can't clear the carbon. As the afternoon heat peaks during Flight 4, the atmospheric conditions make a difficult job almost impossible. Radial engines are entirely air-cooled, relying on the rush of clean air through the nose cowlings to keep temperatures stable. But on a hot tarmac, sitting stationary in a long queue of modern jets waiting for air traffic control clearance, there is no cooling airflow. The cylinder head temperatures on engine number 2 begin to spike dangerously toward the red line. The pilot is forced to open the cowl flaps wide, creating massive aerodynamic drag, while the flight engineer frantically manages the fuel mixture to run incredibly rich, using raw fuel to artificially cool the cylinder walls. It is a stressful, high-stakes game of thermal management. The aircraft finally gets clearance and takes off, but the prolonged heat stress has taken a toll on the engine's internal components. By the turnaround for Flight 5, the schedule has completely collapsed. The concept of a quick, modern passenger turnaround simply does not exist in the world of the Constellation. There are no automated jet bridges. Passengers must slowly climb down steep, outdoor boarding stairs. Luggage cannot be preloaded into standardized container pods. Every single vintage suitcase must be manually lifted, carried, and stacked by hand into the tight underbelly compartments. Meanwhile, the flight engineer is buried under an avalanche of manual inspections. There are oil screens to check, cowl flap actuators to test, and fuel lines to inspect for leaks. The sheer amount of physical labor required to keep the aircraft airworthy means that the ground crew is already exhausted, their uniforms stained with hydraulic fluid and black engine soot. As we look toward the remaining 5 flights of the day, the brutal mathematical reality becomes clear. The Lockheed Constellation was built for an era when labor was cheap, maintenance was highly intensive, and flights were treated as rare premium events that occurred once or twice a day, not 10 times. Attempting to push this mechanical masterpiece through a modern, high-frequency schedule would result in a total grounding long before dinner. The engines would simply overheat, the spark plugs would foul beyond use, and the sheer volume of consumed oil would outpace the ground crew's ability to replenish it. It is a stark reminder of how much the aviation industry has changed. Today's commercial jets are marvels of reliable, self-monitoring, and low-maintenance engineering. They are designed to operate continuously, day in and day out, with minimal human intervention. They have made the world smaller, travel cheaper, and safety almost absolute. But in achieving this monumental efficiency, we also walked away from an era of genuine mechanical soul. The Constellation was a living, breathing machine that required a highly skilled crew of pilots, flight engineers, and mechanics to constantly coax, balance, and maintain its delicate mechanical temperament. It was a partnership between humanity and a beautiful, complex machine, one that defined a golden age we will likely never see again. If you were fortunate enough to see the beautiful silhouette of a Lockheed Constellation in the sky, or perhaps even hear the unforgettable roar of its engines in person, where were you, and what memories did that majestic machine leave with you?